This is Unit 4, Lesson 7. So we're learning the quadratic formula, yet another method that we are going to be learning to solve quadratic equations. This is actually the last of the 4 methods. So coming up in future lessons, we'll be talking about when it would be appropriate to use each method. So quadratic formula is one that works every single time. It's a little bit more complicated than other methods, but it's one that you know will always work no matter what your answers are going to turn out to be. So this is the formula right here. It needs to be memorized. Some of you probably have heard the Pop Goes the Weasel song, the tune, to do this formula. I personally learned it to the tune of the Notre Dame fight song. I could probably be persuaded during class to sing it for you if you guys promise that you'll sing it with me. We'll see. So however it is that you memorize this, it needs to be memorized so that you can just plug all the pieces into the right spots. So we are going to start with equation number 1. Step number 1 here is to write the equation in standard form. You'll notice that a couple of our different methods require us to be in different forms. So like completing the square, we needed the constant over on the right, but in this we want everything over to the left so we know what A, B, and C actually are, so they can be plugged in here, because one sign error will mess up the whole thing. So number 1 already is in the right form. Everything is over on the left. Number 2, identify A, B, and C and then sub them into the formula. So A is whatever is attached to the x squared, so technically a 1 here. B is whatever is attached to the x, that's a 2. C is the plain old constant, which is a negative 63. Make sure you're keeping the signs, whether they're positive or negative, because that could change your formula. So sub into the formula, we've got x equals negative b, so that's a negative 2, plus or minus big square root, b squared, so that means we take the 2 and square it, minus 4 times a, which is 1, and then times c, which is a negative 63. All of that over 2a, so 2 times 1. And then step 3 just says to simplify. So lots of different, multiplying things out, combining like terms, kind of follow your order of operations. So we've got x equals negative 2 plus or minus. Under this radical, we have 2 squared, which is 4, and then minus, so 4 times 1 times 63, that ends up being 200, well, it's a negative 252. So we have minus a negative 252. All over 2 times 1, which is just 2. You cannot cancel these out. People always really want to do that for some reason. We have negative 2 plus or minus square root. When I add these together, I get 256, which is a perfect square. So I'll be able to simplify that in the next step. So this negative 2 plus or minus, the square root of 256 is 16, and then divide that by 2. So we have to do the addition or subtraction before we divide by 2. So let's get our 2 different answers here. So negative 2 plus 16, that is 14, and then when you divide that by 2, you get 7. Or negative 2 minus 16, you get negative 18, divide that by 2, and we get negative 9. So 2 different answers there. I'm going to write it in our set notation. I always write them in numerical order, so those are 2 different answers for that. So do the plus, then the minus, divide them by 2. So that's our first one. We are also going to do number 3. So step 1, write it in standard form, which means subtracting the 1 over to that left-hand side. So subtract 1 equals 0. So we need to have it equal to 0. A is whatever's in front of the x squared, so that's a negative 1. B is in front of the x, so that's 2. C is the constant, so that's a negative 1. Those 3 values are going to get subbed into our formula. So we have x equals negative b plus or minus big square root b squared minus 4 times a times c, all of that over 2a. So sub everything in, now we just start evaluating. So negative 2 plus or minus big square root, 2 squared is 4, minus 4 times negative 1 comes out to be 4. So we have 4 minus 4, all over 2 times negative 1. Remember, you cannot cancel those out. So we have negative 2 plus or minus the square root of 0. So the square root of 0 is just 0. So when you're looking at the plus or minus, adding 0 or subtracting 0 is the same thing. So it actually just ends up being negative 2 over negative 2, because this doesn't mean anything. When you add 0 or subtract 0, it's still just a negative 2. And then when you divide that by negative 2, you get 1. Just a positive 1 is just one single answer. So you almost always have 2 answers. The only time where you will only get 1 answer is if this ends up being a 0. because then the plus and minus don't give you two different answers the way that they normally do. All right, next on this page, we're going to do number 6. So get everything in standard form, which means subtracting everything over to the left. So subtract the 10x. We get this. Identify our values here. So a is 8x squared. B is negative 10 times x. And then c is our constant. We do not have a constant, so it's 0. If you're missing the b, if you're missing the c, that just means it's a 0. So we can now plug in. So x equals negative b, so that's like a negative 10. So it comes back as positive 10. Big square root b squared minus 4 times a times c, all of that over 2a. So the a and the b get plugged in, the c is just a 0 right there. So start cleaning this up. So I have 10 plus or minus big square root, negative 10 squared comes out as positive 100, and then minus 0 technically, so I'm not even going to write that. Over 2 times 8 is 16. So this is 10 plus or minus the square root of 100, which is 10. All of that over 16. So let's get our two answers here. So our two answers, we have 10 plus 10, which is 20 over 16, and then 10 minus 10, which is 0 over 16. So simplify those up and we've got our answers. So 0 over 16 is just 0. And then 20 over 16, you can reduce that down by 4s. So 20 over 16 reduces down to 5 over 4. And that's our other answer. So you could definitely end up with fractions when you're doing the quadratic formula. Keep that in mind. All right, let's look at the next page. We're going to do a few more. So number 8, we'll do that next. Get everything on one side. So that means subtracting all these values over. So we have negative 2x squared. When I subtract 8x, it ends up just as a negative 8x. And then when I add 1, it combines with this 17. So I have plus 18 is equal to 0. All right, so everything over on one side. Let's identify our pieces. A is a negative 2. B is a negative 8. And C is a positive 18. So those three values are going to get plugged into my formula. We have x equals negative b, which comes out as a positive 8. Plus or minus the square root of b squared minus 4 times a times c, finish that square root, all over 2a. Okay, so let's start simplifying. So I get 8 plus or minus square root. When I square negative 8, I get positive 64. Minus, and then 4 times negative 2, that's a negative 8. And then times 18, that gives me negative 144. So minus a negative 144, all over 2 times negative 2, which is negative 4. So keep going with this square root. So 64 combined with 144, that gives me 208. And then all of that over negative 4. Remember, I can't do anything with just these two pieces right here. So 208 is not a perfect square. That is not on my list. But I can split it up, and you might want to play around with a calculator to see what some of these split to. But 208 splits up into 16 times 13. So you can double check if you don't believe me. Well, this splits into root 16, root 13. So we're getting our first one that doesn't come out evenly here. So 8 plus or minus, the square root of 16 is 4, and then the square root of 13 is what's left behind, all of that over negative 4. So these reduce down. Okay, so like this, now all three of these reduce down by the same thing. That's when I'm able to do it. So 8, when I divide that by negative 4, I get negative 2. Plus or minus 4 divided by negative 4 is technically a negative 1, but I have plus or minus. If I did plus a negative or minus a negative, I would still have 1 plus, 1 minus. So I'm not going to throw an additional negative sign in there. That would just make things confusing. It just kind of technically switches the order of the negative signs, I guess. So those are your two answers. So let's write x equals negative 2 plus or minus root 13. So still two answers. They're just actually irrational answers for this one. Next, let's look at number 9. Number 9, get everything on one side by subtracting that 4. So 7 minus 4 leaves us with 3. So I chose this one because there is no x term. So watch what happens when we do that. So a is a negative 8. b is not the 3. There actually is no b because there's no x term. So we write down that that is 0, and c is 3. So plug it into our formula. We get x equals negative b, which is still just 0. There's no such thing as a negative 0. Plus or minus square root of 0 squared minus 4 times a times c, all of that over 2a. So plug this all in. So I have 0 plus or minus square root of 0 minus, so minus 4 times negative 8, that is a negative 32, times 3, which gives us a negative 96. So it's minus a negative 96. So there's just a 96 under that square root. 2 times negative 8 is negative 16. So we can clean this up. So the 96 is actually divisible by 16. So you can't divide these because this one's under a radical and this one's not. But what I can do is split this into 16 and 6 so that I can reduce that radical down. So I am no longer writing the 0. I'm just going to keep the plus or minus. The square root of 16 is 4, and then the square root of 6 gets left behind, and that is divided by a negative 16. So let's reduce this down. So my 4 over 16 reduces down to 1 over 4. So this is now just a plus or minus root 6, because this reduced down to a 1. And then I'm just going to leave this as a 4, because same thing. If I take a positive and divide it by a negative, I get a negative. If I take a negative and divide it by a negative, I get a positive. So I still have one positive, one negative. Now notice these ones cannot reduce, because the 6 is under a radical and the 4 is not. So for my answers, I have some more irrational values here. Okay, last question we're going to do is number 12. So start by getting it in standard form. I'm going to subtract this stuff over. So I keep the 5x squared. I subtract the 4x from the right, and then subtract the 5. So 9 minus 5 leaves me with 4. So that's my equation in standard form. Write down all the pieces. So a is a positive 5, b is a negative 4, c is a positive 4, and after that I sub everything into my equation. So I do x equals negative b, which would be a positive 4, plus or minus the square root of b squared minus 4 times a times c, all over 2a. So simplify this up. We have 4 plus or minus under the radical, negative 4 squared is 16, minus 4 times 5 is 20, times 4 again would be 80. All of that over 2 times 5, which is 10. So clean up that square root one more time. I have 4 plus or minus. When I take 16 and subtract 80, I get a negative 64 under my radical. Now notice that is a negative under the radical sign, which brings us back to those imaginary values. So 64 is at least an even square root. So the square root of 64 is 8. The square root of that negative is what gives me the imaginary I. So the square root of negative 64 is an 8i, and then over 10. So now I can reduce this down. The 8, the 4, and the 10, those can all reduce down by 2. So what I'm going to do is just show you what that will look like. So you can only do this if all 3 are divisible by the same thing. So divide this by 2, divide this by 2, divide this by 2. And that's your reduced version. So we have 2 plus or minus 4i over 5, and that is the most reduced version. These are complex answers because they've got a mix of real and imaginary parts.